Hello, everyone. Welcome to our Wonder Week webinar series. My name is Emily Walters. I am an admissions and PhD recruiting specialist with the College of Engineering. I am joined by Dr. Rolando Herrero today for our session on our master's programs in telecommunication networks and cyber-physical systems. As we go through the presentation today, please just note that the Q&A feature is enabled. I'm going to start out with a brief general overview of Northeastern, and then we will dive into the program content. So most of your questions will likely be answered as we're going through the slides, but please feel free to enter on your questions into the Q&A feature, and we'll get those answered for you. So to start out with just a brief bird's eye view of Northeastern, we are a top-ranked R1 research and experiential learning university. We are ranked #1 in co-op and internships in the country, and we'll talk a little bit more about that and how it directly relates to our programs in just a bit. Northeastern is made up of 10 colleges and schools, College of Engineering being the largest of those. We have over 50,000 students total and degrees all the way to the doctorate level. Northeastern has over $296 million in external research awards. Our main flagship campus is located in Boston, Massachusetts, although we have 13 global campuses across our global campus system. And this slide here outlines a little bit about that global campus network and where we have new campuses popping up. We are beginning to launch some of our graduate engineering programs out on these global campuses. So all of our graduate engineering programs are available on ground at our Boston location. And as we go through the slides, you'll be able to see a bit more of the breakdown of which programs are located on which campuses here. And some of our programs today will be popping up on these global campuses as well. And this is a good outline and general overview of the College of Engineering. As you can see, we have a large student body total of over 10,000 students, and a majority, over 6,000 of those students are graduate students. Like I mentioned, we have PhD degrees, master's degrees, which we'll be focusing on in today's webinar, and over 110 academic degrees, certificates, and minors. We have 403 full-time faculty and 248 tenure and tenure track faculty, and over $104 million in external research awards. We are top ranked at number 34 Best Engineering Graduate School and 35 Best Engineering Undergraduate School in the US. This here is an overview of the different departments that make up the College of Engineering. We have, as you can see, our more disciplinary engineering departments, as well as our multidisciplinary graduate education department. And again, just a little more of a breakdown to give you a better idea of our programs and locations. So we have a total of 9 PhD programs, now over 32 master's degree programs. And to the right-hand side, you can see a bit of a breakdown of our graduate programs that have popped up on our global campuses. So as you can see, we have cyber physical systems in Toronto. And then, of course, like I mentioned, all programs within our graduate school are located on our Boston campus as well. So with that, I will take a step back. I will go ahead and pass it over to Dr. Herrero to go ahead and dive into the program content for today. Thank you so much for joining.
Hi, everyone. Welcome to this presentation. My name is Rolando Herrero, and that's my email. If you have any questions, any concerns, you can reach out to me at that email. I typically respond to you within 24 hours. If I do not respond to you within 24 hours, it means I did not get your email for whatever reason. It's just resent. Okay, so I run 2 programs, Telecommunication Networks and Cyber-Physical Systems. Telecommunication Networks is a program that is highly successful. They have been around since the 20 years ago, since the big days of the internet. And we have had over 1,000 graduates, and it's one of the top two telecom programs in the US. Our main thing is that we are industry driven. These are not your traditional electrical engineering and telecommunications programs, which are more like academia driven. This is industry driven. So a lot of our graduates typically go to work in the industry in places like Verizon, Nokia, Google, Amazon, Apple, big corporations, and also small startups. We have one of the best, in particular the telecom program, one of the best co-op internship placements rates in the College of Engineering. This program is only available in Boston, in US. Next, please. So the question is why a master's in telecom and networking? Well, for the last, I would say 30 years, there have been a migration in which everything related to communications is related to networking, to data networks, and in particular to internet-based protocols. So the internet started like a way to connect computers back in the 70s. Now it's at the heart of everything. Anything from communication between cities to communication between devices, cars, factories, you name it, uses internet protocols. So our program is very centric on networking, data networks, and the internet. And because again, that's what the industry needs, and that's what basically telecoms networks are these days. So with this, we work on everything that is around that, anything related to virtualization, software-defined networks, IoT, 5G, the up-and-coming 6G standards, cloud, edge computing, satellite networks, cybersecurity. In all cases, this leads to very good jobs with consistently very good salaries. Keep in mind is because it's a niche type of knowledge, the demand is big. Next. So why Northeastern? Well, our focus is in industry. As I said, this is not a research degree, so this is not a program in which you're going to be doing mathematical models of communication systems, but actually building communication systems and actually learning about the standards that exist in the industry. So it is one of the top networking programs in the US, as I mentioned before, and this location in Boston makes it centric to support faculty from other institutions like MIT, and also support for internships and full-time jobs. Keep in mind, there are two big centers of high tech in US. One is on Silicon Valley in California. The other one is in what they call the 485 belt here in Boston, right? So these programs are very focused on the needs of the industry, in particular on the softwareization, essentially this migration from purely hardware software solutions into more solutions that are software driven, and even for areas like quality assurance, sales engineering, and so on, right? So not necessarily means you're going to be working in purely development positions, but anything in the industry that is these days is touched by softwareization. So again, we cover different areas, as I mentioned before. We have a lot of flexibility in the choice of electives, and most of the classes are project oriented, so very hands-on. As I said, the idea is to expose you to what the industry needs, and basically prepare you for internships and full-time jobs. Next, please. So as degree requirements, there's a mixture of core courses and electives. There are 3 core courses, 5 electives. So you see it's only 32 credits. Compare this to other, again, academia-driven programs like a master's in electrical engineering. So it's only 32 credits distributed over 4 years. So over 2 years, I mean. They give you an average of 8 credits per semester, which is essentially 2 classes per semester. These are intensive classes, hands-on, as I said, but also give you the opportunity to work on real life stuff, right? Like you're finding the opportunities in the industry, looking at internships and full-time jobs. There is no thesis or project requirement mandatory, but it is optional if you're interested, right? So we offer the support if you're interested on a master project that leads to a master thesis. The reason we do this is because some student wants to move forward and eventually move into, for example, a PhD program in which, a master's thesis is typically preferred as initial step. But many students, they just want to go into the industry where the industry doesn't really care too much about capstone projects. Master thesis, right? So we try to have that trade-off in which you can choose to do the master thesis. So it's not really mandatory. So this is you can take elective classes pretty much from anywhere in the College of Engineering and even at the computer science program. I mean, if you make a case for it. Next, please. The core courses that are required are internet centric. As I said, internet is driving most of the telecom systems these days. And so our main core, but which want to make sure that everybody is well versed on data networks, is on data networking, which provides an overview of an overview with very hands-on overview because it consists also of a lab of data networks. Data networks also is complemented by two core classes, one on telecom and network infrastructure, which provides all the knowledge needed to understand how these networks are deployed and how they exist in the context of systems in the real world, right? And the other one is more on the internet protocols and architectures. This is specific about ITF, ITU, ETSI protocols and technologies that are typically needed to support data networks. So this is a standardization. It's almost like the next step to the data networking class. In data networking, you become with the familiar protocols in which 5360 internet protocols give you a better insight of what those protocols are. Next, please. So we have, as I said, many electives besides the core classes. You can see there anything going from wireless communications, unified communications to cryptocurrency and smart contracts. Remember, smart contracts these days are used in many communication systems, in particular in areas leading to, for example, transactive IoT, supply chains and all of that, right? So we cover all areas, obviously network structures and cloud computing, a lot of focus on that. Note that many of these classes are not just tele classes, but they're also from other departments and they are available to you guys because it's part of what our flexibility is, right? So we have a lot of flexibility in what classes you can take. Next, please. There are also, again, I mentioned softwareization, so there is a big need for software understanding. So there are software electives, essentially anything starting from the understanding of Linux and Linux operations in the context of data networks, all the way to actually development of applications, right? Like phone applications, web applications, development of cloud computing applications, and so on. Next, please. So in summary, right? So data networks is telecommunications. The master of telecommunication networks is basically about this connectivity that exists between everything these days, and it's mostly internet-based, in which there are a lot of protocols, a lot of development, a lot of areas, while the internet, as we know it, is pretty much well established. There are many areas that are in continuous evolution, right? Software-defined networks, IoT, cybersecurity, virtualization, right? Network virtualization, etc. Right? So all these areas are in continuous evolution, and they are fundamental to the next applications of data networks, and it's basically what the industry needs from a perspective of internships and full-time jobs. Now, a superset of telecommunication networks is the cyber physical systems. So cyber physical systems is the other program I run. This program has a focus more on the interaction between physical and physical assets and cyber elements, in particular applications. So think of this, right? So you have assets in the environment. Think, for example, you may have a warehouse. The warehouse has an inventory. It has certain goods. You want to protect those goods, What you're going to do is you're going to put sensors in that environment. Those sensors are going to interact with the infrastructure, in particular with cloud applications that are going to monitor those assets, and potentially they are going to perform some sort of actuation in case something happens. Let's say there's a fire in the warehouse, you want to extinguish that fire, right? So the way you do that is through actuation. So cyber systems is the combination of the physical assets with sensing and actuation happening in the physical world with applications in the cyber world, which typically run on the cloud, that are used to, by means of AI, artificial intelligence, monitor the interactions between the actuation and the sensing. In between those, there are telecommunication networks, but there are very specialized telecommunication networks known as IoT networks. So they're not your standard telecommunication networks that you see under the masters of telecommunication networks. These are a subset of them, which are also presented in telecommunication network program, but it's a subset that is more specific to the interaction between assets and AI. So this is what the cyber physical system program is all about, building those systems. And that involves, again, IoT protocols, essentially IoT telecommunications, physical assets, devices that interact with the physical assets, AI on the cloud, and cybersecurity, right? Because everything is cyber protected by security. You want to make sure that nobody, because these are systems that have no human supervision. You want to make sure that there are no bad actors that may affect your systems. So the cyber systems, after that, they are the system that links the physical world with the virtual world, and we do that through these IoT technologies and protocols. Next, please. So IoT is centric to cyber physical systems, but it's just a component of it. But it's important to understand it. It's basically those technology systems and design principles that are associated with the connectivity between these physical assets and AI systems. And the way we do this is through, again, Internet protocols, but I specialize in the protocol called the Internet of Things protocols. Next, please. Or IoT, by the way. So why is that we can do cyber physical systems are so important these days? It's because there is a need to monitor the physical environment without human intervention. And the reason for that is many different reasons. But one of the issues is, we each time, population count is going down. There's fewer people. At the same time, there is needs to support automation of systems, replace humans by machines. And this basically leads to systems in which you want to have smart manufacturing, essentially industrial IoT, industrial installations in which you basically have a factory pretty much running by itself with very little human supervision, right? That's an example of a cybersecurity system. But there is also other initiatives and other needs, right? Anything from, home automation, building automation, connected health, smart cities, vehicle to infrastructure communication, vehicle to vehicle communication, all of these things where there is no humans involved and machines interact with other machines, right? And rely on AI to make the decisions. All of those are centric to cyber physical systems. Now, besides the human needs, which is basically we need to do this for humans, each time there are fewer humans on Earth. The other thing we can do this for is because we have now the technologies to do it. So we have very cheap electronics, very fast and cheap, low power consuming electronics that have led to improvement in communication, networking, embedded devices, and in particular AI, right? And AI is essentially your brain. So this is what basically provides that automation. So when you combine all of this, you see the need for cyber physical systems. Next, please. So in a cyber physical system, there are basically three components, right? So you have the smart devices. These devices interact with the physical assets. Again, this is your warehouse. You have your devices that through sensing and actuation interact with, for example, the inventory in your warehouse. And you may have like a fire extinguisher there that is controlled through actuation. In addition, on the other end, you have smart applications. These are applications, AI-driven applications that get the sense data and they generate this knowledge that we call the actuation. In between the smart devices and the smart applications, you have the IoT technologies that provide the communication. Again, these are particular internet-based protocols which are fine-tuned to support that interaction between these devices and applications. It's not your traditional internet. In all cases, cybersecurity is key, right? You have cybersecurity at a smart device level, you have cybersecurity at a networking level, you have cybersecurity at a smart application level, right? So smart devices, you deploy them in the middle of nowhere with no human intervention or monitoring, so you want to make sure that nobody's going to tamper and do bad things with those devices. So you have physical security in the devices. In addition, you have networking security, which is the one that you need for the IoT networks to to be secure. And then you have security at a cloud level in the smart applications to make sure that bad actors are not able to authenticate and try to make bad things on your applications, right? So cybersecurity is like an extra layer that expands over all those three areas. Next, please. So what we do here for this program is we have three tracks, right? So these three tracks, they go around those three areas. And the idea is that when you are in this program, you're going to decide basically what track you want to be in, right? It's not this something you have to write in paper. Nobody asks you what track you are in. This is basically for you to keep track of the tracks by yourself, right? So if you are interested in building those devices that interact with the environment, you want to be in the smart device track and take the classes associated with this. If you are more interested in the data network side of IoT, you want to be on the IoT network track. Otherwise, if you're more interested on building those smart apps and using AI, you want to take those classes that fall under the umbrella of the smart apps. Note, and very important, is that industry typically separates these things in actually two branches. In all cases, you need to have IoT knowledge, but the main two branches are the jobs associated with smart devices, and the other area is the jobs associated with smart apps. The type of knowledge, the type of computer languages, the type of technologies that you use in smart devices and smart apps are completely different, right? So if you're more like an electrical engineer type, right, you may have had that as an undergrad degree. Smart devices may be better for you. If you are more into computer science, smart applications may be better for you. But again, that's a personal decision. We do not tell you what track to be in. We do not tell you what classes to take. If you think that your interest aligns with any one of these tracks, we give you a guideline of what classes you should be taking. Next, please. With that, let's talk a little about the reasons for the certificate system programs under Eastern. So locations, right? So this program is available as opposed to the Telecom Networks program, which is only available in Boston. This one is available in both Boston and Toronto. Boston, as I said, is second to Silicon Valley as a high-tech center. In particular, it's a national hub for IoT and wearable devices and predictive analytics. Toronto is the IoT center of Canada, right? Those are reasons. We have a lot of interaction with standardization bodies, with industry. We have our own lab here. We have a club called the IoT Connect Club, which is run by students, which, for example, right now is working on a hackathon for the fall. We have basically the support of the College of Engineering and all the classes they provide. Our co-op program, internship program, is also one of the better ranked at the university for both undergrad and graduate. Next, please. So as I mentioned, we have a lab. The lab is on our fifth floor of Dana in Boston, opened in 24 last year around this time. It supports classes, applied research, industry events, hackathons. Next, please. We work on a lot of R&D projects on it, and we support a lot of events and hackathons that are shown there. For example, now we're working on hackathon, which is gonna happen in the fall 2025. Next, please. So let's talk about the program itself. We have courses that cover all areas. So we have one IoT specific core class. We do have one application specific core class. And application, I mean basically a cloud computing type of application specific. We have one core class that covers the device side, right? So out of the core classes that we have one of each area. So you become familiar essentially with this general knowledge of that you need for the cybersecurity system program, right? So in addition, as I said, we have all the back of College of Engineering with all the classes they additionally have, right? Anything from network and wireless communications, data science analytics, software engineering, databases. Great flexibility, probably as no any other program in the College of Engineering. We have great flexibility in choosing your elective courses because again, we're industry oriented. We want you to do well in the industry. So we want to make sure you're prepared to face the industry, right? So if you have a specific need and you say you want to take a class in a particular area, as long as you make a case, you can typically take that class. And most of our projects are oriented. Our classes are project oriented, so you're going to be building things, and this will lead you, to co-op opportunities and internship opportunities and full-time job opportunities. Next, please. So let's talk about the degree requirements. So we have 4 core classes you need to take. Again, 32 credits only for 2 years. We're talking about 2 classes per semester. Enough time for you to do. I know classes are intensive, but they give you also opportunities to work on the stuff you need to go into the industry, right? So anything from providing, working on these on volunteer projects, working on hackathons, on events, and stuff like that. Besides participating in clubs and other things that are available at Northeastern, right? So we have a lot of opportunities to complement what you do class coursework wise, right? So you have 2 required core courses you need to take. One is on fundamentals of IoT, and the other one is on connected devices. Those are fixed classes you have to take, and then you need to choose 2 between 3. In total, you need to take 4. Remember, right? One is on introductions to IoT smart device design. This is mostly on the hardware side. Programming hardware side. This is stuff you do purely at this lab, in which we provide the hardware to you and you do build systems. Then we have another one more on the analytics side, on the cloud computing, which is machine learning for IoT, essentially AI for IoT, which is time series based, right? So one of the things that happens in the type of AI you run in cyber systems is highly dependent on data that is sampled over time. So you need to process that data. That data is called time series data. So that class is focused on that. It's very specific to cyber physical systems. If you are interested, and let's say you do not have the programming skills to support, other electives you may want to take, alternatively, you can take also a class on object-oriented programming, which is supports, software development, right? At least you need to take, besides these 4 core classes, you need to take 4 other electives. There is no thesis or project requirement in Boston, but many students do it anyway. We have a capstone project and a thesis that you can do in Boston. In Toronto, the master project is mandatory, by the way. Next, please. And by the way, let me talk about that. So one of the things we're doing in Toronto right now is for the capstone project. If we have students work with companies for the capstone project. So right now, our capstone project, we have 3 students that are working on a project for a company right there. So it's also a good experience to get familiar with the market. Next, please. So this is a few of the electives. Again, I'm not going to go through every single one of them for sake of timing, but you can see that the focus of these electives is smart devices, is smart applications, and there are a lot of options there. I mean, a lot of electives for you to choose from. Again, anything from building these smart devices to building those IoT applications that will process the data generated by those smart devices, right? Again, you only need to take 4 electives, so you have more electives than you can choose from. Next, please. Again, if you are more interested into the communication side of cybersecurity systems, you have the IoT protocols and architecture electives too, right? Keep in mind, that's more on the data networking side of things. Typically, our recommendation is not to focus too much. If you're on cybersecurity systems, try to integrate smart devices with IoT protocols or smart applications with IoT protocols, because that's going to open your doors for the industry, which basically what they want is they want to build applications, right? It's a little different than the requirements on telecom networks program. Next, please. We have another big differentiator is we have faculty that is on both sides of the on both sides of the spectrum, right? So we have faculty that are people that are working in the industry that they, in addition, they're faculty, and some people that are purely academic faculty people or that have been in the industry in the past. Most, if not all, have been in the industry for at least 20 years. So they know what's going on in the market, they know what the market needs, and they have contacts in the industry. Next, please. This has led also to the for most of us to write books, which are used in our classes, but also in classes all over the world. So we have really, really good understanding of what the needs are for cybersecurity system students. Next, please. They have led to the development of an industry board that includes people from important C-level, C-suite employees from many, many different companies, startups, corporations, big corporations, small corporations, etc. Next, please. So the admission criteria is shown there, right? So you want to have a GPA equivalence of 3.0 to 4.0 undergrad. Again, this you need to take with a grain of salt, because if you can prove industry experience and other experience that may be relevant, that can be put into consideration, right? So it's very important that when you write your letters and your application state what else you have done that may be relevant to help in your application, right? So industry experience is desirable. So if you have industry experience, it's good, again, because our program is very, very industry experience centric. You do have to have, there's no need for the GRE and so on, but we recommend you have experience in software development and programming. And this is not just this program. Pretty much, if you're going to go to the industry and anything STEM related these days, you need to have programming skills. If not, you're gonna be in trouble. In our particular case, the assumption is that you have some basic knowledge of some sort of programming language. Anything like Python, Java will do it. If you are more into hardware and building devices, C, C++, Rust is a good thing. We do cover those languages as part of the program, but if you have any previous experience, typically helps. Okay, next, please. So we have the co-op. The co-op is typically only once you can do it, but you have to take a class which is called ENCP 6000. That class is Career Management for Engineers. This is mandatory for you if you want to go into a co-op. Co-ops are typically 4, 6, or 8 months maximum, and basically is something that will enable you to apply what you learned through the coursework. Next, please. These are the timelines for the co-ops, right? So if you're doing 4 months co-op, and again, this is up to you and the company you go for, you can start at certain times of the year for that 4-month co-op. The same thing with a 8-month co-op, right? So depending on how long it is, you have different time frames for it. Next, please. So these are some of the companies our students have gone to, not all of them, some of them. So you get an idea, a big range of different companies, stuff like Meta, Arista. Meta is a big corporation, Arista is a smaller corporation. Startups, right, too. Okay, next, please. So there are minimum requirements for the students to go on co-op. Is GPA have to be above 3.0, I believe now. I think they changed that. So still you need to have a pretty good GPA. You have to have completed the MCP 6000 class. This is a one credit class that you take in your first semester. You need to have completed 16 academic credits. That's essentially two classes besides the NCP 6000. And basically you need to have all the, visa requirements and so on, which I'm not really familiar with. So that's not my area. But essentially, you need to make sure you comply legally to be able to go to co-op. Next, please. Actually, I think that should be the X. So I passed the. So I apologize. Yeah, that should be the last slide. So I pass back this to Emily. Thank you, Emily.
Thank you so much for diving into the content of those two programs. Again, if anybody has any questions, now would be a great time to enter those into the Q&A. I'm just going to wrap up by talking a little bit about next steps and some timelines. But first, I just want to point out a wonderful resource that we have within the College of Engineering. We have what we call our graduate ambassadors. These are current graduate students who are in our programs, living it day to day, went through the same application process and are now students at Northeastern, just as you anticipate to be. This QR code will lead to a website with many different ways to contact our graduate ambassadors. You can send them an email or contact them on social media. They're wonderful resources if you have questions about what life is like as a student at Northeastern. Of course, in admissions, we're more than happy to answer your questions when you're going through the application process and all of those technical things. But there's really no better resources than the current students in these programs. So we definitely highly encourage you to go ahead and reach out to them. So I will talk a little bit about next steps. We likely have applicants at various stages in the process joining us today. So for those of you who have not yet submitted your application and are considering doing so, I just want to briefly go over our admissions requirements. For the programs that we spoke of today, they're both master's programs, and the good news is that we no longer have application fees for our master's programs. So if you're applying to any of our master's programs within the College of Engineering, you should have no issues. You will not be required to pay an application fee. If you are interested in a PhD program, I know sometimes students apply to many programs. You will be required to pay an application fee. However, at these webinars, we do like to provide a fee waiver code, which you see here. So this is a great slide to screenshot. Again, if you are considering applying to a PhD program. We do require 2 letters of recommendation. You'll be required to submit your unofficial transcripts at the time of application. You will be required to submit your resume as well as a statement of purpose. If you are joining us from internationally and the mode of instruction at your institution where you received previous degrees was not English, you will be required to take either the IELTS, TOEFL, or Duolingo English proficiency exam. You can see that there is a line through GRE. We no longer require the GRE as part of the admissions process. However, if you've taken the GRE and you believe that your scores will enhance or supplement your application, you're more than welcome to submit those during the process. And I just want to point out some dates here. I'll start with the spring 26 application cycle as it is quickly nearing an end. As you can see, November 1st there is the application deadline. For all international students, whether you're currently residing in or outside of the US, and the application deadline is December 1st for those of you who are currently living in the US. I'm sure many of you are anticipating applying during the fall 2026 application cycle. And so if that's the case, a couple additional deadlines I'd like to point out here. We do have priority deadlines for the fall cycle. So that's going to be December 1st for all PhD applicants and January 15th for master's applicants. Of course, we do continue to accept and review applications after these deadlines, but in order to receive priority review, we do highly recommend applying by those priority deadlines for consideration. We continue to accept applications for international students currently outside the US until June 1st. That's going to be July 1st if you're an international student currently residing in the US or Canada, and then August 1st if you are currently in the US or Canada. This slide here points out some scholarships that we're offering for both the spring and fall 2026 cycle. We often have program launch scholarships when our programs are available on different campuses. Cyber Physical Systems is currently running a scholarship that for the program in Toronto. I know that's one of the programs we covered today. And otherwise, here you can see for our different engineering programs that are currently offered on those global campuses, we are also running additional scholarships. So this is just a snapshot. I do encourage you to visit our website to dive a little bit deeper and read a little bit more into the stipulations of these scholarships, but nevertheless, a great opportunity. And that is all that we have for today. Um, Again, if you have any questions, no matter what point you are at in the application cycle, please don't hesitate to reach out to us in admissions. You can see here we have our COE-grad admissions at northeastern.edu. We have a wonderful operations team who is closely monitoring that inbox, and we'll get to your question as soon as possible. And if we're not the right people to answer that question, we will ensure that we pass you on to the correct department, whether it be the Office of Global Services, a faculty member. Again, another plug for our wonderful student ambassadors who are extremely helpful in helping you navigate Northeastern and what it's like to be a student at Northeastern, what it's like to be a part of these programs that we mentioned today. So I want to thank everybody so much for taking the time to join us. Thank you so much, Dr. Herrero, for your time and
Thank
diving
you.
into these programs. And I don't see any additional questions here in the chat. We do have just a moment or so if there's any questions that we can address before the time is up today. I'll just give them a
Yeah,
minute.
and also if they have if any one of you have any questions, don't hesitate to contact me. I mean, I'm gonna be able to answer technical questions, like class related, content related, industry opportunity related type of questions. I'm basically based on where you want to go in, in the industry. You can reach out to me if you have any interest in getting an answer. Thanks.
Thank you again. All right. Well, it looks like we don't have any. Oh, I'm sorry, actually, as I speak. One question, is there an option to take some business classes?
Yeah, that's an excellent question. So let me give you an example. So most of our students are technical students, right? So they want to be engineers, they want to do engineering. So we had in the past a few students that they did have previous experience on the industry, but more on the management side, more on sales engineering. They were interested in moving into something more like product management, right? And for product management, you have to have a good intersection between technical knowledge, in particular, knowing about specs and stuff like that, but also some business knowledge. So for those particular cases, if you can make a point of, you can take classes on a business side within the engineering offering. There is a bunch of engineering offerings that are related to program management, program management, project management, and business by themselves. You need to make a point of it. If it makes sense, yes. So these particular students I'm thinking of basically took half of his classes were non-technical. I mean, he took the core classes, but then went more into the non-technical side because he was interested in being a program manager, product manager. And right now he went just in an internship of project management, product management in the South, and now he's back finishing his degree. So it is a possibility, but you need to make a point of it, right? So it's not like because you need special permissions for those things. You cannot register for those classes. So you need to have what it is submit a petition for that. But in your petition, you need to make a case that you can do that. So, but yes, if it makes sense, yes.
Wonderful. Thank you. Great question. All right, so that looks like that's it, and we are at the end of our time for today. So thank you again so much, everyone. Best of luck in the application process. We look forward to receiving your questions and seeing your applications come through. I hope everyone has a wonderful rest of their day, and thank you again, Dr. Herrero.
Thank you, Emily. Thank you, everyone. Hope to see you here. Thanks. Bye.
Thank you. Bye, everyone.